5 to C.
Heard of CRISPR? I would be shocked if you hadn't. This is a technology, it's for genome editing, and it's so versatile and so controversial that it's sparking all sorts of really interesting conversations. Should we bring back the woolly mammoth? Should we edit a human embryo? And my personal favorite, how can we justify wiping out an entire species that we consider harmful to humans? If you're trying to CRISPR a genome, the first thing that you have to do is damage the DNA. The damage comes in the form of a double-strand break through the double helix, and then the cellular repair processes kick in, and then we convince those repair processes to make the edit that we want and not a natural edit. That's how it works. The devil is always in the details. We don't really know that much about cells.
I'm Dr. Maggie Liu. Welcome back to my channel. This week, we'll be talking about a recent research study that used a genetic engineering technology, CRISPR, on the International Space Station for the first time.
Like, hi! Like, hi! Yeah, totally. I mean, I know,
We all know DNA. It's the recipe to each and every person and every living thing. It's what makes us unique.
Totally, I mean, I know,
DNA carries information or instructions, as you will, that define our characteristics. Scientists would blast plants and animals with radiation to change their DNA information. Would by chance alter some characteristic that the scientists were interested in. The technology is based on a naturally occurring process in the body where protein cells known as Cas9 will take a segment of DNA code and clone it. Cas9 will search for that segment, and each match that it finds elsewhere, it will cut out. It removes the information that DNA segment holds. With astronauts Christina Koch and Nick Hague on board the ISS to look at double-strand breaks, or DSBs for short. DSBs are a type of DNA damage where the double helix is broken. To do this, they flew an organism into space on the ISS, where its DNA sequence was edited via the CRISPR technology. CRISPR purposely inflicted breaks in the DNA of that organism. And the reason that they did it was that astronauts may be at risk of similar harmful DNA damage caused by ionizing radiation in space. Such DNA damage can lead to cancer and other detrimental health effects. And it's really important that we can address these issues. The CRISPR method mimicked genetic damage caused by cosmic radiation, and this allowed the researchers to achieve precisely controlled cuts in very specific locations of the DNA sequence.
There's going to be a lot of breakthroughs on the medical front, particularly around synthetic mRNA. I mean, I think with enough, with effort that's not too crazy, you could probably stop aging, reverse it if you want. You can basically do it. You can turn someone into a freaking butterfly if you want with the right DNA sequence.
But also, this eradicated the risks caused by accidental damage.
Whoops.
This was the first time that CRISPR has been used successfully in space. I am so looking forward to see what CRISPR has in store for us. It would be amazing if one day we could just edit our genes and, for example, breathe in space without a spacesuit.
Totally. I mean, I know,
That's all for this week's video. I'll leave the publication in the description box below if you want to find out more.
Let's stay connected.